Always put parentheses around the denominator. Always put parentheses around quantities under the square root. So be careful with that. Yes, I'm ready.
Can we do number 4?
Yes. Good. Number 4. 3, 4. Yes. So find the country's population in this, and what appears to be happening to the population of the country every 27 years. So we are given f of x equals 542 times 1.026 raised to x. X years after 1970, x equals 0 means 1970. And they're asking us what happens in 1970, in 1997, 2024, and 2051. So what does that mean? What are we asked to do? We're asked to find f of 0, then f of 27, yes, f of 54, and f of 81. Of course, I'm not going to do this sequentially. I'm just going to put it in the function in y equals. So let's do that. So in y equals, clear if you have anything else, and plug in 542 multiplied by, or parentheses, whatever you want, 1.026. Close the parenthesis, power. The power is only 1, no operation. It may work without parentheses. I refuse to do it because I'm old-fashioned. Your calculators may work. I never like to risk this. So go second and table, and I plug in 0, and I plug in, no, not 2. I plug in 0, I plug in 27, and then 54, you said, and then 81, you said. Good. So I write 542. I write 1084, and then 2168, and then 4335. What appears to be happening to the population of this country every 27 years? It appears that it's doubling. Perfect. Next question. Yes?
On
Chris?
the test,
Yes?
it'll just say just like to solve the equations for the equation. Like we just need to know what type of equation it is to solve, right?
Yes. So it's very important to identify it correctly, right? If it's exponential, I do certain things. If it's log, I do something else. Right. Yes, that's very important. Identifying the equation correctly is super important.
Question.
Yes?
On the calculator, is the independent supposed to be in auto mode or ask to?
So the independent always in ask.
Okay.
The dependent you cannot touch.
Okay.
Yeah. I have no idea why that is an option in there.
When's our final exam? Is that going to be that Saturday?
So that Saturday, we will review the 11th.
Okay.
I will be here for you starting, let's say, from 1 o'clock or so.
On the 11th.
Oh, the 11th. Yes, we'll also review next Wednesday. I will return your test 3 graded. Don't forget, I'm adding a bonus, a couple of problems, maybe 2 or 3 problems, 4 problems, for a certain number of points to be added to test 2 grade. So if you want to come in early to work on test 3 plus the bonus, please come in early. I will be in 314. Where that class is torture.
314 on Wednesday or just on 11th?
No, only on Monday.
Okay.
for the
Yeah.
test. If you want to start early because you also have the bonus for test 2.
Okay.
And then when I'm done there, then you come up with me
For regular class time.
for the to continue working on the test. If you need extra time. If you don't need extra time and you have enough time from 5 till 8:30, then you come here at 5. I mean, 4 hours should be, 3 hours and a half should be
Oh, I
enough.
was confused. I thought you were giving the extra credit questions on Wednesday. That's what,
No,
on Monday.
they are after your test 3.
Okay, perfect.
And nobody's obligated to work on those. But I recommend you take that opportunity to increase your grade on test 2. Please
And
do.
it'll be something that was on that test. not
On
the
that
same
test,
question.
same
Okay.
type of questions, of course. Absolutely the same. Okay, what would you like me to continue with? Because I have a wonderful lady right here waiting for 2 problems. For the next 3 hours, for the last 3 hours she's waiting. So, is there anything else from test 3? That's the first priority at this moment. Where are you going? I'm kidding, I'm kidding, I'm kidding. I don't want you to go. Okay, any
It's just review, right? For this test. For the
if there are other questions, if not, I'll start the review for the final.
oh, today?
Yes.
Oh.
Yes. Yes, number 13.
Well, the final's gonna have everything on it. A little bit of everything.
Yeah, you can watch this.
Okay.
Sure, yeah.
Okay.
Number 13. Okay, very good. So we have A of t equals 543.3 e to 0.02 t. Describes the population of a country in millions t years after 2003. So t equals 0 means 2003. Use the model to determine when the population of the country will be 733 million. Round to the nearest year. So, any ideas?
Wouldn't the 733 be where AT is?
Excellent.
Trying to find
Wonderful. 733 equals 543.3 e to 0.02 t. Excellent. Well done. Then what?
Divide by 540.
Of course, clean it up. Indeed. Excellent job. Then, absolutely. The left-hand side is what it is. Natural log of 733, 543.3. The right-hand side is
72.
yes. Final step before we plug it in, the calculator.
Natural log 733 over 543 over 0.02.
Very good. So please calculate and give me the answer. They can delay it much longer, don't worry.
Okay.
Just kidding. They have to face the truth at some point in time. So what did we get? So approximately 15 years since 2003. So it is 2018. Well done.
Can you put that into the calculator?
Yes, of course. So here it is. So, oh, here. Natural log in parentheses 733 divided by 543.3. Close the parenthesis. Since there is only one factor at the top, it's fine. Divided by 0.02. No parentheses are needed. So roughly 15 years since 2003, which is 2018.
I forgot to natural log.
That's okay. Is there anything else from this test that you would like to review? Any type of problem, anything that you think that we should look at again? Anything? Okay, so we have here two piecewise defined functions that we would like to start reviewing for the final exam. Ready?
Are those on here? Or those are just
No,
separate?
no. This is Priscilla's creation. She said, I want this, I want this. We have to comply. Ready? So this is for the final exam review. There is no question, no doubt, you will have a piecewise defined function to graph. So this is a perfect start of the final exam review. Ready? So here's the first function, f of x equals x plus 2 for x less than or equal to 1, and 4 for x greater than 1. Okay, and then we'll go back to the second one. Okay, when I'm asked to graph a function, obviously I have to start with the domain. I have no choice. The domain is crucial. And I don't know what the domain is, but I know that this is negative infinity to 1. Would you agree? And I know that this is 1 to infinity. And this should give me a very good idea of what the domain is. Can anyone identify the domain by looking to the left of 1 and 1 and to the right of 1?
Negative infinity to 1 bracket, then union 1 to infinity.
Is there another way of writing that?
Just negative infinity.
Excellent. Negative infinity to positive infinity, that's perfect. F of x, negative infinity to infinity. 0 must be in the table no matter what. But now the crucial value is 1. This symbol is under 1 to the left, and this symbol is under 1 touching to the right. I only copied the symbols. So now I write on the table so I don't forget. Which function will I use between negative infinity and 1? You can say it's right there under your notes. True, but I like to write it.
X plus 2.
Do you all agree with x plus 2?
I'm kind of. How did we choose x plus 2?
For x between negative infinity and 1,
Okay.
I have to choose x plus 2.
Okay.
Because that's what I'm told.
Yeah.
Good. Now from 1 to, that's why I write it, just to make sure that this is clear. For 1 to infinity, which function do I use? 4 indeed. Let's plug in numbers. I'm also going to plug in negative 2 because that's an x-intercept. So let's plug in negative 2. What do I get? Let's plug in 0. What do I get? Let's plug in 1. What do I get? Inside the bracket. Let's plug in 1. What do I get? Indeed. Let's plug in 2. What do I get? What do I get?
So 8. 8.
Just 8, right?
Is there an x to plug in? No. So when I plug in 2, what do I get? So let's read the function. The function is 4 for any x between 1 and infinity.
Okay.
So when we plug in 1, what do we get?
4.
When we plug in 2, what do we get? Very good. When we plug in 3, what do we get? That's it. There is no x in there in which anything changes, right? So let's read the function one more time. The function is 4 for any x between 1 and infinity, but not 1, of course. Is that clear? Excellent. Now, if I have x, 4x, then it's a different story. This is 4, this is 8, this is 12, and so on and so forth. But I don't have it. There's just one number. Very good. It's a constant, in other words. Good. From left to right, please dictate the first point. Excellent. Please dictate the next point. Please dictate the next point. Is this a full point or an open point? Excellent. Because of the bracket. Next one. Next point. Full point or open?
Open.
Of course. If there is a full point, there cannot be another full point. 2, 4. 3, 4. So this is the graph of a piecewise defined function. And what if I ask now find the range? Carefully find the range. Negative infinity, comma,
3.
bracket, union.
4 to infinity.
Does it go to 4 to infinity, or is it just 4?
Sorry, 4.
Just 4.
How did we get the 3 again?
I'm sorry?
How did we get the, I know how we had negative infinity, but how did we get the 3?
Exists, 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 exists. 3 exists.
Okay.
No, no. 4, yes. No, 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 no. From negative infinity to 3, union 4. There are gaps. Gaps at above, gaps in between. 3 and 4. Perfect. We have another. We want to look at one more. So here it is. F of x equals x squared minus 9 over x minus 3 for x not equal to 3, and 6 for x equals to 3. Okay. Of course, I'm going to work on this because I can. Let's take it aside. Is there anything we can do to this? Yes, I factor the top. How? Excellent. 3 is not in this domain, in this piece, so I can simplify. What do I get? Good. So now please dictate the function again, the simplified form. Yes. Excellent. And 6 when x equals 3. Way more human. Good. So then we have to find the domain. How do I write this? Negative infinity to 3, union 3 to infinity. That's what it means. Anything on the planet except 3. That's what it means. And this one says x equals 3. So then what is the domain of this function? You have everything but 3, and I have 3. What do we have together? Everything. Negative infinity to infinity. You have everything but 3, and I step in and I say, look, I brought my 3. So what do we have together? Everything. Good. So then, which is the key point or x value? Of course, 0 must be there, but the key value is
3.
indeed. But this time, careful, this is what we need to do. So please pay attention for a second. Left and right, they're not touching. And what do I write inside? What do I write inside?
6.
6. When x is 3, y is 6. But I don't know these. In a moment, I will. Good. Which function do I use on both sides of 3 except at 3? You're right. Right, so when I plug in 3, I get 6. When I plug in 3, I get 6 is not going to be an open point.
It's explicitly for both.
Yes. Left is x plus 3, right is x plus 3.
Okay.
Good, so let's plug in some numbers. Of course, I'm going to plug in -3, and I get 0. I'm going to plug 0, I get 3. I'm going to plug 3, I get 6. I'm going to plug 3, I get 6. I'm going to plug in 4, and I get 7. And I'm ready to graph this when you are. From left to right, the first ordered pair. Very good. Then I should put an open point. However, 3, 6, I have to fill it in. 4, 7, and I have to continue. It turns out that it's just a straight line, no gaps. Now, if the function is given as this, for example, being -2, then we will have an open point here and -2 here. But it happens that this is 6, this is 6, this is 6. So the function, it's smoothly, yep, no gap, no jump. Can anyone give us the range of this function?
This is negative infinity to positive.
Exactly. The range, negative infinity to positive infinity. We have 15 minutes left. Let's start with any of this or everything, or if you want to go back to what we need to review for test 3, or if you want to go back and review something from test 2, since we have that bonus.
Oh,
Two
I
more
have
weekends,
questions from
two
test
more
2.
weekends before the final exam. I will redo both tests, test 1 and test 2, several times this weekend. Yes?
Can
So?
you do the first problem from test 2? Yeah.
Yeah, I don't think I have a test 2. I don't want to waste your time and look for it. Can I copy it? Thank you. First problem. Yes. Negative x plus 1 over x times x minus 11 less than or equal to 0. Perfect. Ready? Luckily, this is all factored already. Factor, factor, factor. So having 3 factors, I have to present them in a table. Negative x plus 1, x minus 11, and ratio, the whole thing. Because I ran out of room, like I always do. So what numbers do I need at the top? One number that makes this 0, one number that makes this 0, and one number that makes this 0. in order from left to right.
First one would be 1,
Correct. The second one will be,
0,
and the last one will be,
11.
very good, 0, 1, and 11. Great job. There is a 0 in each row. And the first row is under, good, negative leading coefficient. It looks like this, from positive to negative.
Wait. So how did we just do that? How do we know?
Plug in a number, negative 5. Negative 5 with minus in front is 5. 5 plus 1 is positive. Plug in a number on the right-hand side of 1, 10. Negative 10 plus 1 is negative. Or you think that you graph this and it looks like this, from positive to negative. Chapter 3.
So if you plug in a negative number.
Negative to the left of 1. Any number to the left of 1.
Okay.
You will get a positive number no matter what. Because it looks like this. It comes from positive infinity and goes to negative infinity. It's a negative leading coefficient.
And then for
A linear function with a positive leading coefficient looks like this. Comes from negative, goes to positive. If it has a negative leading coefficient, it's coming from positive going to negative.
I think that's why I messed up on it because I had all the negatives on the opposites.
Just plug in a number. If you don't want to think in terms of the end behavior, right? This is important for graphing polynomials, right? So if the leading coefficient is positive, the end and degree odd, degree 1, if the leading coefficient is positive, it looks like this. If the leading coefficient is negative, it must look like this. Is that clear?
Okay.
The leading coefficient is negative.
Mm-hmm.
When we graph a linear function with a negative leading coefficient, we have to graph it like this. There is no other way. So it has to come from positive, go to negative. I don't have to think. But if you say, let me think and plug in numbers, plug in numbers. But you must get the same thing. Is that better?
Mm-hmm.
Yes?
Yeah.
Rachel, is this okay?
Yeah.
Okay, so x is 0. Leading coefficient is positive, so it's negative and positive. 11, 0. Leading coefficient positive, so it must be negative and positive. So then we have, for 1 is 0, but for the other two is undefined. Because x and x minus 11 are in the denominator. And now I see two negatives. So then I get positive. I see one negative, so I get negative. I see two negatives, I get positive. I see one negative, and I get negative. Better?
So you put the 0 for that row, the ratio row, you put the 0.
When the numerator is 0, the entire ratio is 0. But when the denominator is 0, the fraction is undefined. So that's why at 0 and 11, the fraction is undefined. Is that better?
Yeah.
So is that clear, the sign?
Mm-hmm.
Two negatives will give us a positive. I don't even count the positives. They don't mean anything. They don't change anything. So one negative, two negatives, and one negative. But I'm asked to find a negative. So what do I pick? I pick the negative. So it's this and this. So x in the interval, parentheses 0, 1, but a bracket at 1 because I'm allowed to have 0 because of the equal symbol. But union, I'm not allowed to have 11, infinity. Is this better?
Can you
Yes?
just say again how you presented this, like how you presented it in interval notation?
This is the interval notation.
Can you just like talk it through and explain it through? Because I don't.
So I'm asked to find x that this is less than 0. This ratio is less than 0 here for these x values, and it's less than 0 here for these x values, corresponding x values. So 0, 1, 11 to infinity. But I cannot take 0, so it has to be open. I cannot take 11, so it has to be open. But it's this interval and this interval because of where the negative is. If this were reversed, I would have chosen the positives, this and this.
Infinity, negative infinity.
Negative infinity to 0 for the positive, union 1 to 11 for positive. So positive is for these two, and positive is for these two. That's where I see the positive.
Okay.
Better?
Yeah.
Perfect. Anything else that you would like to go back to from test 2?
Can you do the synthetic division?
Yes, of course. Can I get a copy for a moment, or if you want to read it to me?
X to the 5th plus 2x to the 3rd minus x plus 1 over x plus 2.
Very good. So in the box, what do I have? Negative 2. What is the degree? What is the degree? Good. What is the coefficient of x to the 5th?
1.
Coefficient of x to the 4th?
0,
Coefficient of x cubed?
2,
Coefficient of x squared?
1, -1. Alright. 0.
Perfect. Coefficient of x?
Negative 1.
Excellent. Free term? Good. Power 5, power 4, 3, 2, 1, power 0. Yes?
How do you get negative 2? Why is negative 2 in that?
Because it's x minus a. And I have to compare, and then it means that this is x minus negative 2. So a is negative 2. That's how I have to put negative 2. Better? Perfect. So now we bring down 1. Let's start. Negative 2 times 1.
Negative 2.
0 minus 2.
-2.
Negative 2 times negative 2.
4.
2 plus 4. Negative 2 times 6.
Negative 12.
0 minus 12.
Negative 12.
Negative 2 times negative 12.
24.
24 minus 1. Negative 2 times 23.
Negative 27.
In the box,
Negative 25.
remainder. So when we divide degree 5 by degree 1, which degree do we get?
4.
4. Very good. So the answer would be
X 4th.
minus.
X
X to the 3rd.
Very good. Plus.
6 to the 3rd.
Minus.
12x.
Plus.
23.
Minus 45
Over x minus.
x plus 2.
Yeah.
Very good. That is the synthetic division.
Can we do? I have no test. Can we do number 5?
Yes, of course. Can I get a copy? Number 5, you said? Okay. Very good. A ball is thrown, blah, blah, blah. Okay, so we have f of x equals negative 0.8x squared plus 2.4x plus 6. X is the ball's horizontal distance in feet. Remember my silly example. And what is the maximum height and how far will travel till it hits the ground? Good. What type of function is it?
Quadratic.
Good. Does it have a max or a min?
Max.
Why?
It's negative.
The negative leading coefficient. How do I find the maximum? Finding the vertex. Remember, there is no other function that has a vertex. That's why I asked, what type of function is it? You said quadratic. It has a vertex. If you say cubic, there is no vertex. If you say linear, there is no vertex. If you say natural log or exponential or radical or whatever, there is no vertex. Just the quadratic function has a vertex. Perfect. How do I find the vertex? Negative b over 2a. Negative b. 2 times a. Negative 1.6. Two negatives. Of course, I cannot throw it up that way and I have a negative coefficient. Well, actually, for you, I will throw it this way, right? Okay, so then whatever I get, what is it? Good. How do I determine the maximum height? Exactly. F of 1.5. So negative 0.8 times 1.5 squared, 2.4 times 1.5 plus 6. Let me know when you get this answer. Yes? What is it? Okay. Feet. Good. And now they want us to determine how far from the point where I'm throwing it up and up and over, it hits the ground. So what am I really asked to find?
What is it?
Exactly.
Wow.
This, which is the the x-intercept when y is 0. Correct. So negative 0.8 x squared plus 2.4x plus 6 equals 0. I solve and I get whatever. One of them will be negative, which I don't need, but one of them will be positive when I apply the quadratic formula. Any questions?